Good evening, everyone, and welcome to another Reactor Signal live stream. Today, we are looking at machine learning in C#. So this is an introduction to ML.NET. We are joined with Will, who's one of our Microsoft Data Platform MVPs who's based in New Zealand. So I thought I'd just cover some quick things in the beginning. If you do have any questions, please put them in our Q&A box and we'll answer them at the end. And just to let everyone know that this session will be recorded and shared on our YouTube channel, and I'll put those links in the Q&A for you as well. So without further ado, I'm going to hand you over to Will. Thank you, Will.
Awesome. Thanks, Nadia. Good evening, everyone. Welcome to this session, Machine Learning in C#, an introduction to ML.NET. My name is Will Valida. I am a software engineer working for ASB Bank, so the cousin of CBA here in Auckland, New Zealand, and I'm also a Microsoft Data Platform MVP. And this session is really designed just to introduce you all to ML.NET. You don't have to be an expert in machine learning. You might be a hardcore .NET developer. You might be a student. You might be a data scientist wondering how to do machine learning in C#. And so this session is really just to introduce you to what ML.NET is. Yeah, just a little bit about me. I've been living and working in Auckland for coming up to a decade now. It's been a long time. I'm slowly starting to like the All Blacks, the rugby team, but I still hold an affinity for Arsenal Football Club. As you can probably tell by the accent, I'm originally from the UK. My day-to-day job, I'm a C# developer. I work with a variety of different technologies ranging from Azure Cosmos DB, Azure Functions, Event Hubs, Service Bus, Azure Storage. But in my downtime, when I get the chance to hack on some projects, I like to play around with ML.NET when I can, hence the talk to you all today. And I'm a recent Data Platform MVP awarded back in April this year, which was a nice day because that was that was a weird day because it was our first day of lockdown, so it was a bittersweet day. Anyway, what will we be covering in today's session? So I'll start off by going over at a very high level what ML.NET is and what kind of predictions we can perform using ML.NET. I'll then talk about the different ways of how we can actually use ML.NET to build machine learning models and the tools available to us, ranging from the model builder to the command line interface tool, right up to the API itself when we want to build more customized solutions. That slide's a little bit out of date. I'll talk a little bit about ML.NET performance, but throughout the session, what I'm going to be doing is I'll introduce the tool, talk about it at a high level, and then I'll perform a demo for you just to show you how the tool works. So hopefully the technology will will favor me today. As of half an hour ago, the demos were working, so let's hope they keep up the good form. And like Nadia said, at the end, we'll have a Q&A session. So if you do have any questions, pop them in the chat. And at the end, we'll have a bit of a Q&A session, and I'll be happy to answer them then. Cool. So what is ML.NET? Essentially, ML.NET gives us the ability to add machine learning capability to both our online and offline .NET applications. And using ML.NET, we can actually perform machine learning to make predictions using the data available to us within our applications. Central to ML.NET is the idea of a machine learning model. And essentially, when we build a machine learning model using ML.NET, we will specify the steps needed to transform the data that we input into our machine learning models, and then transform that data to make predictions. Using ML.NET, we can train a custom machine models by specifying the algorithm that we need, or we can actually leverage other libraries and import pre-trained models. For example, we can actually have models that are trained using TensorFlow and Onyx, and we can actually import them using ML.NET into our C# applications. And then once we've trained our model, we can actually add the model that we've trained to our applications in order to make our predictions. So what kind of predictions, or what type of predictions can we make using ML.NET? So in ML.NET, we can perform a variety of different predictions due to the different tasks that we can perform using ML.NET. Now, what a machine learning task is, it's a type of prediction being made based on the problem that we're trying to solve with the data that we have. In ML.NET, we have a variety of different algorithms available to us based on the type of task that we need to perform for our scenario. Now, I've got a link here to all the different types of algorithms available to us, but essentially we can perform classification tasks. So say if we've got a customer feedback website and we've got a form, we can actually do some sentiment analysis on that text to determine whether that feedback was negative or positive. We might be predicting the price of a product. So through all my demos today, we'll be using a taxi fare prediction. We're creating taxi fare prediction service using a variety of different tools. And for this, we would use regression machine learning tasks. We might be building applications to detect fraud or fraudulent transactions, and we can perform that using anomaly detection machine learning tasks. We might want to build recommenders. So we might have a e-commerce site and we want to suggest products to our customers based on their previous purchases. So we can build recommendation applications using ML.NET. We might want to forecast the cost of a taxi trip over time. So we might want to do time series or perform sequential data machine learning tasks. And of course, we can do image classification tasks using ML.NET, just analyzing pictures to classify what this image actually is. So how can we build models in ML.NET? So when it comes to building models, we have a variety of different options available to us. Now, we have two low-code options, and this is both the model builder tool and the command line interface tool. Or we can opt for a code-first option to build more customized machine learning models actually using the ML.NET API. And what I'll do is I'll actually go through each tool and show you all how we can build models with it and just explain it a little bit. Cool. I'm just going to turn my phone off silent, on silent. Okay, so let's start with the ML.NET model builder tool. So the model builder tool is a graphical tool that we can use to build, train, and deploy machine learning models. It uses AutoML, which essentially automates the process of applying machine learning to our data to explore different algorithms that we can use or we can apply to our data, and it will find the best one to suit the problem that we're trying to solve. The great thing about the model builder tool is that we don't need to be experts in machine learning to use it. All we need is our data and the problem that we're trying to solve. And what the model builder tool will do, it will try to find the best algorithm to suit our problem, and it will generate the code that we need to add our model to our .NET application. Really straightforward, and it's really simple. So let's crack into that demo. Okay, let me test my first transition of the evening. Okay, what I'll actually do, I will show you all. So the model builder tool is essentially an extension that we can apply to Visual Studio. Now, if you're using a Mac, or if you're using Visual Studio for Mac, unfortunately, you won't be able to use this tool. It's limited to Windows. But if you're running Visual Studio on a Windows machine, you can just simply download that and you'll be ready and raring to go. So what I've done is I'll actually increase the text size a little bit, even though we won't be doing too much coding in this demo. Essentially, what I've got here is a .NET Core console application. Very simple Hello World one. And to actually get started with the model builder tool, when you install that extension, I can just right-click my solution and just add machine learning. So I'll open that up. And when we first kick off the model builder tool, we'll have to select a scenario that we want to train our data with. And we've got a variety of different scenarios that we can use. So we can use text classification, value prediction, which is the one we'll be using. We can perform image classification using the model builder tool. And this is really quite cool because what you can do is you can actually hook this up to an Azure machine learning workspace. So if you've got that provisioned in Azure, you can use that as your training environment. but we're going to be sticking with value prediction just for this demo, but we can also do recommendations, object detection models, etc. So I'm going to click on value prediction, and then we select our training environment. So for regression, we can only use our local environment at current time of speaking, but if we were doing our image classification scenario, we could actually connect that to our Azure Machine Learning workspace if we had that. So I'll choose my local training environment. And then next, we can add our data to for the model builder tool to pick an algorithm for. So for our input, we can choose either just a file, either a CSV file, TSV file, or a text file, or we can import our data from SQL Server. But what I've got is I've got a CSV file here. And then once I've loaded that, what I can do is I can pick the column that has the values that I want to predict, otherwise known as a label, and I can choose my input column, so our features. So what features do I need in order to predict my label? So for this, what we're going to be predicting is how much a taxi fare ride will cost. So I'll pick the fare amount. And then for input columns, I can pick the vendor ID, so who's the taxi company, what the rate code is, how many passengers, how long the trip took, trip distance, and how they actually paid for it. So what I'll do is, for this one, I'll just take out trip time in seconds. And then once we have defined our features and we've defined our label, we just click next step. And then we specify a time to train to evaluate various different models. Now, this time to train in seconds will depend on the size of your data. So it's picked a default 10 minutes here. If you pick a lower value, depending on the size of your data, there is like a minimum amount of time that you have to train your data for. But what I've done is I've already done this for you, so you don't have to sit there watching me train a model for 10 minutes. And essentially, what I'll do is I'll actually kick it off to show you how it starts the process. So what it will do, when it starts training, it will start going through your data and then iterating over that data using a variety of different models, a variety of different algorithms, sorry. And it will assess how effective those algorithms are by just generating some statistics here, or just, some metrics, sorry, here in the output. So in that 10-minute period, it will just reiterate over and over that data set and just find which algorithm is best suited for the problem that we're trying to solve. But what I've done, I've actually, this is one I made earlier, so half an hour. So after your training is complete, we can see a little bit of a summary here for the experiment, so we can see what type of machine learning task we wanted to perform. We can see the data set that we performed it on, see the label, how long our experiment took, and how many models it explored. And this is just a really good way of assessing what different models were used. So say if we wanted to train it using different features, we can experiment and just play around with that and see if which algorithm actually solves our problem. But what it's done is it's shown me the best quality fit, so the best fit algorithm with the best fit. So that's an R-squared value of 0.9189. Told me the best model, so it's a light GBM regression model, and the training time and the number of models explored. So once we can do that, click on next step, and then we can actually do like a little bit of a test on our models. So we've got some sample data that it's just pre-populated from the first row of my data set, and by clicking predict, we can see a predicted result based on the model. So if that looks right, if it looks like a realistic value, what we can do is we can then accept this model, going into next step, and we can actually add the code, or generate the code in order for us to consume our model. So if I just add to solution, what it will do, it will generate 2 C# projects. So this project will contain our model. So there's our ML model, which is our serialized version of our model. We have an input class. So essentially, if we were to train this model again with new data, we could use this class to actually load new data into the model again. And this is our output class. So there's our score for our predicted label. And then we have some code here that we could potentially use to actually consume the model. And then in this program file, let me just increase that. We can make a sample prediction, play around with that, and just see how effective it is. And just see how we can actually inject that model once we've built it into our .NET applications. So there's a very quick, very simple example of the model builder tool showing you how simple it is to really generate train a machine learning model without any prior experience in machine learning, and then generate some C# code in order to consume that model. Okay, get back to slides. Okay, before we move on, there are some limitations that we need to bear in mind when using the model builder tool. Like I said, the model builder extension is currently only available for Visual Studio on Windows. I believe that they are working on a extension for Visual Studio Code. So if you're using a Mac, keep an eye out for that. But I think that's the model builder tool itself is still in preview. So the extension, I think, is still a little bit way behind. So it's just something to keep an eye out on. You are limited to your training dataset size of 1 GB. And if you're using SQL Server as a training input, that has a limit of 100,000 rows for training. So those are just some limitations to keep in mind when you're using the model builder tool. Okay, let's move on to the command line tool. So the ML.NET command line tool is essentially a .NET Core tool. And what you can do is you can provide it with a machine learning task and a training dataset, and it will generate an ML.NET model as well as some C# code that you can use to run a model within your applications. Now, there are some pros and cons with the command line interface tool. So one of the limitations is that we are limited in the types of tasks that we can use. So as of this talk, these are limited to classification, regression, recommendation, and image classification tasks. But this is a developing tool, and I believe it's open source. So more tasks are being added as it's being worked on. But the plus side is, unlike the model builder tool, it's cross-platform. So it works on Windows, Linux, and Mac OS. So if you've got a Mac and you want to use ML.NET from the command line, if you want to use the command line tool, you can totally do that. Now, when we use the command line tool, what it will do, it will generate our serialized zip file, which contains our model, along with a C# solution that we can use to both train the model again for future use and run the model so we can make predictions. And we'll also get a log file, which essentially shows us the information of all the multiple algorithms that were assessed and evaluated. So you may have noticed when we were looking through the model builder tool, we had a summary of all the algorithms that were assessed in our output. That actually gets generated to a log file. And we can use this to investigate other algorithms that were assessed. So if our scenario changes for whatever reason, we can actually use this as a source of investigation. All right, let's jump into our second demo. So what I've got here, I've got my command line interface tool. So in order to actually install it, I've installed it already, but what you can do, just make sure got everything in place. Yeah, okay, so in order to install it, all we need to do is just run .NET tool install, and we can install this as a global tool, ml.net. And that's a really simple way of actually installing the command line interface tool. But what I've done is I've done that already, and I'm just going to type in ml.net. And when we type that in, we see we've got a variety of different commands and options that we can use to actually use the tool. So as you can see here, we've got these 4 types of tasks available to us to use in the command line interface tool. So our classification, regression, recommendation, and image classification. But in this file directory, what I've got is let me just bring it up on screen. I have got a CSV file containing our training data that we're going to be using to try and generate a machine learning model that performs regression so we can predict taxi fare trips in the future. I had it open already, so I've got my data set here. I've got a column for vendor ID, so who was the taxi cab company that performed the ride, what the rate code is, how many passengers, how long the trip took in seconds, the distance, payments, and the fare amount, etc. But what I'm going to do is I'm going to close this file. No, I don't want to save it. And what I'm going to do is I'm just going to generate a regression model for us. So in order to do this, I am going to start off by typing ml.net. And then I want to give it the type of task that we're going to perform. So in this case, it's going to be regression. Then I need to provide my data set. This is a file, taxi fare train.csv. Just double check that's the file name. Yep, fantastic, cool. And then what I need to do is I need to provide it a label column. Now, you may have noticed this in the input and output classes that were generated by the model builder tool, but essentially what we'll need to do, how ml.net works, it works on zero-based indexing. So when we provide it the feature, we'll need to provide it its position based on zero-based indexing. Now, having run this command just over half an hour ago, my feature, my label column is our fare amount, which is column number 6. Then we need to tell the command line tool whether this file has a header or not. This is just a simple true or false value, and it's true because I do have a header. And then I can specify the train time. And again, this is the train time in seconds. So don't worry, I'm not going to make you all watch me train this model for 10 minutes, but I'll just put in 10 minutes for now. And hopefully that will kick off the training. Yes, fantastic. I typed it in correctly. And just like the model builder tool, it will actually start iterating over our data and assess which algorithm has the best fit for the problem that we're trying to, for a regression task for the problem that we're trying to solve. So here's one I made earlier. And here is that output. So here's our here's the command line interface tool iterating over our data, assessing which model is the best fit. So producing some metrics, how many iterations, and then we have this nice summary like before. So again, I've got my machine learning task that we wanted it to perform, the data set that we used, what was the label, what's the label that we're trying to predict, how long our experiment took, and how many models it explored. Now, what this will do, it will actually, for some reason, it's generated a log file in the temp folder, but oh well. What it will do, if I go into the CLI command line interface tool, oh, it's actually, damn it. Okay, slight change. What I'm going to do is I'm actually going to show you guys a command line interface tool. What it will do, it will generate a C# solution, which will contain our model and our console app. This is from a conference that I did. Gave the same talk at a conference not too long ago, so I'll show you that. But essentially, what it will do is within the directory where you run the command line tool, it will generate this C# project. So just waiting for Visual Studio to load on my other screen. Come on. All right. Just come up to here. And this is one I made earlier. So essentially, we've got our model, our C# our project for our model. So we've got our serialized zip file here. Again, here's our input. So this is what we provide to ML.NET to actually train our model. So we've got our column names and what position they are, at what index they are based on the file. Then we've got a class for our output. And then in our program file, we've got a way to actually make prediction, or a way to consume our model and make predictions on it based on our input sample data. So again, just the CLI is really just a simple tool. If you have a data set that you want to try and solve some problems with, if you have a problem in mind, if you can use the command line interface tool to just run a very simple command. It will generate, it will iterate over your data, suggest an algorithm for you to choose, and then just generate some C# code for you to inject into your applications. Cool. So let me go back to presentation. Lots of switching of screens. Cool. All right. So that was the command line interface tool. So now let's talk about the API. And the API is really a code-first approach to actually building more customized machine learning models for our applications. And what I'll do is I'll actually break it down into the separate components, show you the workflow, and then we'll dive into some demos. So when it comes to the API, each ML.NET application will start with something called an ML context object. And this is a singleton object that contains something called catalogs. And what these catalogs do is that they provide methods for that enable us to perform a variety of different operations that we need to build our machine learning pipelines. So we'll have catalogs to load our data, prepare our data for our pipeline, training the algorithm that we want to use to solve our problem, and then use the model once we've actually trained it. So we can start with getting our data. Now, using the API, we can actually load our data from files, or we can load our data from external sources. So if we're loading our data from files, we can load data from a single file. We might have multiple files within a single directory that we can use, or we might have multiple files in multiple directories. And we can use, if we have any of one of those combinations, we can use that. We can use the ML context data catalogs to actually load that data into our ML.NET application. We can also load data from a variety of different relational data stores, and this is supported by the system.data namespace. So if you have relational data in SQL Server, Azure SQL Database, Oracle, SQLite, Postgres, you can use that data to load into your ML.NET applications. Or we can even load data from in-memory collections or JSON or XML sources using the load from enumerable method. Now, this method will assume that that IEnumerable object is thread safe, but if you have JSON data sitting in Cosmos DB, or if you're working with in-memory collections, you can actually use that to train your machine learning models as well. Now, when we load our data, what we do is we load them into a data view object, and we do this for transformation. Now, data view objects are core to pipelines in ML.NET. And when we perform transformations using data view objects, each transformation will have an input schema. So this will be the data names, the types, and the sizes that the transform will expect to see as an input, and an output schema, which will be the data names, types, and sizes that the transform produces after we've performed our transformation. And essentially, what ML.NET will expect is that if the output of one transformation doesn't match the input of the next transformation, it will throw an exception. So that's just a way of making sure that our pipelines can run smoothly. And data view objects are only loaded and operated on during model training, evaluation, and prediction. Now, once we have our data, we'll need to prepare our data in the format that it's expected by the algorithms that ML.NET provide. I'm sure if you're a data scientist, you'll know that the majority of your time will be spent on actually cleaning your data, working with missing data, working with different types of data. And the data operations catalog actually provides a number of operations that we can use to make our data acceptable for use in our ML.NET applications. It has a variety of different operations that we can use to actually take our incoming data and essentially produce an iData view, which is like an object that can tabularize our data, which will contain our data that's ready for use in our applications. And we might be performing a variety of different operations, such as filtering data, normalizing it. We might want to work with text data. Within my demo a little bit later on, I'll show you how we can work with categorical data. They're just essentially what the data operations catalog does. It provides you with all those operations that we can use to actually clean our data and put it into an acceptable format for ML.NET to train their algorithms. Now, depending on the nature of our data and the problem that we might want to solve, our approach to data preparation will change. The thing to note here is that all algorithms in ML.NET will expect a float vector of a known size as an input. So essentially what that means is we need to convert our data into a numerical format and then process that into a features column in order to predict our label. So in this little code snippet here, what we're doing is we're creating an output column for a label, for the label value that we're trying to predict. And then we're transforming our categorical data by applying, I've got some categorical data here, and I'm just going to be applying some one-hot encoding on the 3 input columns and then producing 3 output columns. So I'm transforming this categorical data and then just transforming into an output column, just performing that one-hot encoding. Now, essentially, if you don't know what one-hot encoding is at a very high level, what it will do is it essentially takes a finite set of values and removes implicit ordering within our data. So for example, say if I've got categories for payment type, some customers are paid by credit card, some customers are paid by cash. What it will do is it will take those categories, turn them into a binary value, and then it will remove the ordering of that value. So if you pay by a credit card and that gets turned into a 1 value, essentially that will, and you've got another category for checks, and that's given a 2. It will remove the ordering from it so it doesn't think that 1 is more important than 2 or vice versa. Now, once we've transformed our columns, essentially what we're doing here is we're now concatenating them into a vector column called features. And that will just, that will be all the features that we choose to try and to predict our label, which is our fair amount in this case. Once we've done all this, once we've transformed our data, we then append our algorithm that we want to use to solve our problem. And then once our data is processed, we use the fit method in order to train the machine learning model with our regression algorithm. Now, in order to make a decision on how well our model will perform, we need to evaluate its performance on test data. And we can do this using the evaluate method. Now, depending on the type of machine learning task that we're performing, different types of metrics will be generated. But in this example here, what I've got is I've got my test data that I've loaded into a data view object, and then I'm using our defined model that we defined earlier to make predictions on our test data. And then what the evaluate method here, it applies to regression. So when we evaluate our predictions to the label that we're trying to predict, it will generate metrics that are relevant to regression. So in this short snippet here, what I've got is I've got a regression metrics object, and I'm just assigning the R-squared valued to the R-squared property for the metrics that we've generated. And then once we've trained our model, we can actually save and save it so we can use it in other applications. Now in ML.NET, when we build our models, they're only available in memory. So when we stop that application, we'll lose our model. So in order to keep it, we'll need to save it. Now in ML.NET, the process of saving and using models are universal to all different types of algorithms that we can use in ML.NET. And when we save our model, we need two things: the model itself and the data view schema of the model's expected input. Now, when we load our model, we can simply call the load method if we're loading a model that's stored locally, or if we're trying to use a model that's stored remotely, we can use a stream for that. And then once we have our model, we can input our data to make either bulk predictions or a single prediction at the time. And for this purpose, we can create something called a prediction engine, which is essentially a class that helps us make predictions. So in this example, I'm calling the predict method here, and I'm passing both the model that I want to use and some input in order to make the prediction. Now, this example here is using a prediction engine pool, and it's important to bear in mind that the prediction engine class or the prediction engine object isn't thread safe. So if we're making a single prediction, that's fine, that's okay, we can use a prediction engine object. But if we want to make multiple predictions, we'd have to create something, if we were to use the prediction engine, we'd have to create instances of this everywhere, and as our application grows, this isn't manageable. So the answer to that is we can actually create a prediction engine pool, which I'll showcase in a demo in just a bit. And essentially what this does, we can use this with dependency injection, and it will create an object pool of prediction engine objects that we can use throughout our application. So let's recap just the workflow of how we can actually use the API. So we'll start off by collecting and training our data in preparation and load that training data into an data view object. We can specify the pipeline of operations in order to extract features, manipulate data, and then apply a machine learning algorithm onto it. We can then train our model by calling the fit method onto our pipeline and then evaluate it and use the metrics generated from that evaluation method to assess its fit or iterate on it to improve its effectiveness and fit. If we're happy with our model, we can save the model into our binary format and then use it into our application by loading the model back into an iTransformer object using the load method. And then we can make predictions by calling our create prediction engine, or through our create prediction engine class, and calling our predict method. Cool, so let's jump back into a demo. Now I've got two demos for this. One is a very simple console application. So here we go. All right. Now, this is one I've built earlier. But in order to actually get started with ML.NET, this is a simple console application, and what we can do is just type in Microsoft.ml, and this would be the base class library for us to actually use ML.NET within our applications. And I've installed that already, but as you can see down here, I've got different types of libraries that we can use depending on the type of algorithm or depending on the type of operation that we're going to be performing. So as you can see, I've already downloaded, already imported Microsoft.ml.fasttree because I'm going to be using a fast tree regression algorithm. But I've got all these different types of libraries here from NuGet that we can import depending on the type of application that we're going to be building. But as you can see, I've already got Microsoft.ml and Microsoft.ml fasttree, and some of these I know that Microsoft.ml has some of these libraries in there already, so you don't have to install data view, CPU math, and yeah, cool. Anyway, going back to our demo. So what I'm doing is I'm just going to be building a pipeline from the ground up in this demo. So as you can see here, I've got some testing data and training data in just a local file called data. And I'm setting my training data path to this training data set here, and also this test data path to the CSV file here. And then I've got a model path. So when I save my model, I'm just going to save it to this model.zip file, which will be in this data folder here. So like I said, when we start building applications using ML.NET, using the API, we start with our ML context. And then we can load our data using our data catalog, our data operations catalog. So here I'm just loading from a text file. Now I've got this input class. So as you may have seen in the demos earlier, it actually generated our input and output classes for us, but here I've actually created it. So I've got my properties for vendor ID, rate code, passenger count, trip type, etc. And I'm using that zero-based indexing to tell ML.NET that these will be the columns. When I'm using my local CSV file, those will be the index positions to look for these properties. And then I've also got my output class as well, which will be my score column for the fare amount. So I'm loading that there, and I'm loading it using the training data path. We can actually specify whether the file has a header or not, just like the command line interface tool. And we could also tell what's the separator character within our text file. Once we've done that, we're building our pipeline. So we're actually copying our columns to define our label column using the fare amount. Then we're applying our one-hot encoding to actually perform one-hot encoding on our categorical data. And then we're concatenating our features. So we're taking our vendor ID encoded, rate code encoded, passenger count, trip distance, payment type encoded. And we're saying these will be the features that we want to use in order to predict our fare amount. Then we apply our training algorithm onto our pipeline. Once we've done that, we fit our dataset view onto our pipeline to actually build our model. And then we're performing a little bit of testing. So very much like we're loading our training data, we've got our test data path there. We're then using that test data to assess its fit, generating some metrics out of it, and then making a prediction or creating our prediction engine object so we can actually make our prediction on this sample data set here. So I'll put some breakpoints in and let's give this a run. All right. So what I'll do is okay. So I'm creating my ML context, loading my training data set, creating my pipeline. So I'm performing those transformations, defining my label, concatenating my features, applying the algorithm. Then I'm going to be fitting my pipeline onto our model, onto our data set to build the model. This will take some time. We haven't produced any output yet, but then once we have our model, we'll load our testing data set, and then we'll be using this testing data set to actually assess our metrics. So what I'll do is I'll be generating these metrics. So we've got the R-squared value, absolute loss, squared loss, and root squared loss. And bear in mind that different algorithms will generate different metrics. So here I've got an R-squared value of 0.88, so it's 88% fit. And then we can use this to actually make some predictions. So I'm creating my prediction engine model. Cool, so there will be my taxi fare prediction. So there's my fare amount. So that's just a very simple way, or just a step-by-step process of actually building, using some training data, creating a pipeline, fitting that pipeline to generate on our training data set to build our model, some simple evaluation, and then just using a sample prediction to generate our prediction. So that was a simple step-by-step view. And that was just making a single prediction, just a single prediction of building our model and then just generating a single prediction. But what I've got is I've got a little bit more sophisticated example for you. So I have two projects here. Essentially, what we're going to be doing is we have two Azure functions. So this function is a model trainer. And what it will do, it will take our local training data set here and actually train our model and upload it to Azure Blob Storage. And then I've got an API which will then consume our model that we trained from Azure Storage. And we can use that model to make predictions on future taxi trips, and it will persist it to Cosmos DB. So what I'll do is I will actually start this model trainer first. Now I've built a bunch of helpers just to abstract the process of actually connecting to our storage account and uploading it. So essentially I'll actually increase the text size there. Not the greatest real estate, but I'll connect to my Azure Storage client. So I've got my local data set for training and testing, just defining that, and then I'm defining a model path as well. And then I've got this train and save model method. So come into here, I'm loading my local CSV file into that iDataView object. Then I'm going to be training my pipeline again, transforming the column that I want to use as my label, performing a little bit of categorical one-hot encoding onto my categorical columns, concatenating the features that I want to use to predict a fair amount, and then applying my regression formula onto it. And then I'm going to fit the model. Just wait for it to go. Remember, I'm using my local machine, so it shouldn't take too long. And then we can evaluate the model. So I've got this evaluate method here. I'm passing in my model, and then I've got my test file that I want to use to actually evaluate my model on. Again, using generating some metrics for regression. I'm just using the R-squared value here. So what it will do, it will return an R-squared value, which is, let me just go over that, again, 0.88. And then we can actually use this. So say in a scenario, we want to be able to either accept or reject a model based on the fit. So here I'm saying it's quite a good fit. And what I'll do is I'll actually save that model to blob storage. And then once I've saved it, we can actually upload it. And then if we go into my blob, so I've got a storage account here. So if we go into I've created a container. Oh, not where I wanted to go. To actually upload my model. And there it is. There's my serialized model that we've built in ML.NET. And now this will be available to us to consume from a remote location. So that's training our model. So if I just stop that. So now we're going to actually consume that model into another Azure function, which I've just built as a serverless API. And here I've got my input models. Again, I've got the object that I'm actually going to insert into Cosmos DB. And then I've got a class there for my output prediction. Now within my startup, what I've done here is I've added a prediction engine pool. And for this, we'll need our input class. So that's our taxi trip, and then our output class as well. So the prediction that we're going to make. And we have a couple of methods that we can actually use for this. So here I'm using from URI. So I'm essentially telling my function that, hey, this model that I want to use within this function is stored at this remote location, which we can provide. So this is just the location that it's stored in my Azure Storage account. And then we have this period parameter that we can essentially what happens here is we provide it a time span that we say, okay, poll this remote location every minute to detect any changes within the model that we've uploaded. So essentially in the background, you could actually run the model trainer so many times a day. And what this will do if it will actually poll that location and detect any changes within the model and then apply that and use that latest version of that model. And you can also, this is just for a remote location. If you're storing this locally, you can actually use a different method. I think it's from path directory. And essentially, again, it will just work on a file polling system as well. But this is for a URI that we've got for our model that we stored in Azure Storage. And then here, what we're going to be doing is when we fire this up, I'll actually fire this up now. We'll take in our incoming post request. We'll deserialize that into our taxi trip object. Oh, did I start up my model trainer? Yep. Let me start up my API instead. That's better. There we go. All right, let's kick that off. And I'll actually go back into cool. Okay, so I'll deserialize that into my taxi trip class, and then I'll pass that input into my prediction engine pool, and then use that input to make a prediction on our taxi trip model. So you see here that the model, we've given the model a name. Now, when we define this, when we actually define this in our startup class, we can actually give this model name whatever name we want. But when we use it within our applications, we'll have to give it the same model name. So you can choose whichever name you want for your model, but you have to keep it consistent once you've named that model. And then once we've made our prediction, we'll try and insert that into Cosmos DB. So what I've got Postman ready and waiting to go. Make sure my function has started up. A lot of log output. Yep, so there's my function. It's ready to receive post requests. So what I'll do is I'll just change this up a little bit. I've got a passenger count of 2. I'll use a rate code of 1. This trip took me half an hour. Auckland traffic is not too bad. I only went 5 kilometers though. Makes sense. Pay by credit card. I'll leave fare amount as 0. We'll send that post request. And I've included some breakpoints so we can go through this step by step. So I've got my incoming request body. I'm deserializing that into my taxi trip input class, making the prediction. And then I've got this insert class that I want to use to actually insert into Cosmos DB. And I'm returning the value, so that looks all good. I'll just stop the API. Oh, I did it too early, but what we can do, if we go into Cosmos DB, I've got a database and container ready to take in my taxi trip predictions. And that was the one I did earlier. And there it is. So there we go. There's my input, and we've got a predicted value here of $18. So there's a bit more of a sophisticated end-to-end application that you can use that kind of demonstrates building a model, then loading it and saving it into Azure Blob Storage, and then being able to consume that model in another application. But hopefully that's demonstrated a little bit of it's been like a straightforward demonstration of how you can actually build models and then use them using the API. Cool, so what we've covered today, we've gone through what ML.NET is at a very high level. At a very high level, we discussed what kind of predictions we can use using a variety of machine learning tasks. And then we went through the different tools that we can use to build our machine learning models. So the model builder tool and the CLI tool, which can be really simple low code options that we can use to generate machine learning models for our .NET applications. And then we took a bit of a deeper dive into the API itself and how we can actually take a code first approach to have more granular control over the models that we build for our applications. And then we went through a couple of demos. Now, if you want to learn more, I believe these links are being posted into the chat. But essentially, the ML.NET team have built a bunch of samples that they're hosting on GitHub. So there's samples in C#. If there are any F#ers out there, there's also some samples in F#. Just showing you some different applications, different scenarios that you can perform in ML.NET. If you want to read the documentation, their documentation is fantastic. I definitely recommend checking that out if you want to learn ML.NET from the ground up. I've got the code to the serverless price predictor that I've showed you just now. That's a link to my GitHub if you want to clone that, have a play around with the code, maybe extend it, and just learn a little bit more about how that works. And I've also got links to the model builder tool if you want to install that. Also the ML.NET CLI that also shows you how to install that onto your machine. And then coming up, starting on the 13th of November, there's actually a virtual hackathon that the community have organized in association with the ML.NET team. Essentially, it's a virtual hackathon. There's a bit of a conference around it. So if you're a data scientist, if you're a software developer, software engineer, whatever, if you want to get hands-on, dive into solving problems with ML.NET, I definitely recommend checking out that virtual hackathon. Or maybe you have a problem that you want to solve and you want to play around with .NET, I definitely recommend pitching an idea to the hackathon and seeing if you can form a team around trying to solve that idea. Cool. Well, thanks for listening. Thanks for coming. If you want to connect with me on Twitter, ask me any questions via there. I'm pretty active on there. Or if you want to just connect on LinkedIn, there's my LinkedIn page. Yeah, thanks for coming. It was great presenting to you all. Does anyone have any questions?
We do have some questions that have come through, Will. So just to touch on that as well, I have added all the links that Will mentioned in the slide previously before, so you'll be able to find them in the chat. Okay, so the first question is, what kind of data processing happens in the background when using the model builder? In brackets, normalization, categorical field, encoding, etc. Any evaluation metrics exposed, for example, R2?
So in terms of data processing, I think the model builder tool isn't that sophisticated. So essentially, it will take your data as an input that you've defined it as. I think the only kind of manipulation that you have with the model builder tool is choosing which columns you want to use as your features. If you do need to perform more sophisticated data processing, which is probably quite likely, this is what you'd use the API for. And in terms of evaluation metrics exposed, I'm not entirely sure what you mean by that, but I think once you've generated your model, it will show you some evaluation metrics, if that's what you mean. I don't think it's exposed anywhere else until you've actually generated the code for your solution.
Awesome. Okay, so the next question is from Andre, and he asks, what are the data input limitations for machine learning console version?
So for the AP, is this for the command line interface
Yeah.
Okay, cool. That's a very good question. I think it's very similar to the model builder tool where you just define your data set. And I'm not sure if it has the same limitations like the model builder tool where the training data set has to be 1 GB of size, or if you're defining it anywhere else. If there are any other limitations, I'll have to come back on that. As far as I'm aware, there aren't any, but I wouldn't be surprised if there weren't.
Awesome. Andre's also put in another one as well. I think it's kind of more of a statement. And Andre asked, I think machine learning in C#/VS is easier to maintain models than in Jupyter Notebook. Would you agree?
Coming from a very biased software engineering background, I would say yes. The one, in my experience working with data scientists and data engineers, is when they can build a really sophisticated end-to-end solution using Jupyter Notebook, but it's very difficult to productionize it. There have been challenges productionizing it, and that's just my experience. So what ML.NET does, I believe, it actually lowers the bar of entry into production. There are some limitations compared to other machine learning libraries, and obviously, I think the translation of, I think data scientists might find it a little bit more of a challenge actually moving from Python or a SQL like workflow into C#. But just generally, if you're thinking about moving in your machine learning models into production, ML.NET is a really, really nice way of doing that. And I think it does lower the bar of entry.
Perfect. We don't have any more questions, but I just want to pop out there. If you do, please put them in now. So while you all do that, just going to give a very quick update on some events that are coming up at the Reactor. So I want to say a big thank you to Will and for everyone for joining us this evening. If you do want to see the events that we have up and coming, or you want to RSVP, you can join our community at meetup.com/Microsoft Reactor Sydney. You can follow us on Twitter, and the session will be recorded and uploaded to our YouTube channel, which I will also share in our meetup page as well, and I'll pop that link in the Q&A. If you do have any questions about the Microsoft Reactor, or you're keen to get involved, feel free to email us at reactorset@microsoft.com, and one of us will get back to you. So I have popped the link in the description. So if you've got any feedback on today's session, if you could please leave it at aka.ms/reactor survey. And we do ask if you could please leave the event code in the survey as well. So it just lets us know which event you are referring to. So a couple of events that are coming up. We've got one coming up on Thursday, which is MS Dynamics 365 integrations with the Azure ecosystem. So Dynamics Finance and Supply Chain Management can be integrated using Azure Logic apps, and Faisal, who is one of our community influencers, will be taking you through that session on Thursday. We do have another one coming up next Tuesday on transparency and algorithmic decision making, so pulling back the curtains on AI. So this is going to be delivered by one of our Microsoft regional directors, David Goad. He's ran a few sessions for us before. So he's going to ask the questions like, how does transparency both positively and negatively impact people's perceptions of algorithmic decision-making processes? I do believe he has a blog around this as well, which we'll be able to share with you next week. So I don't see any other questions that have come through. Again, these are the links to join our community. You can also sign up to be part of our monthly newsletter as well, so you can see all the global events that we have up and coming. Will, did you have anything to add?
Just a quick question for you. Say if anyone in the audience did want to, or thinking about presenting, is that open to? Is the Reactor open to first-time speakers?
Absolutely. So what I'll do is I'll pop my LinkedIn in the chat. So, you know, if you're really keen to, you know, you're looking at becoming part of our MVP program, or you just really want to share some sessions around the technology that you're passionate about, feel free to send me a note on LinkedIn. I'll pop it in the description. So yeah, absolutely everyone is welcome.
Awesome. Otherwise, apart from that, thanks for having me. This was awesome. I haven't spoken to a Sydney audience before, even though it's virtual. It was cool to be able to do that.
Well, we enjoyed having you, Will, and thank you so much for taking us through that all and all the links that you provided as well to help everyone else continue on their journey.
Awesome.
All right. Well, thank you all for joining us. So good evening, good afternoon, good morning from wherever you're tuning in, and we will see you all next time. Bye for now.